My name is Uli Hansen, and I welcome you to the presentation of MSG Lithoglass. Today, I will talk about microstructured glass and silicon components for optoelectronic packaging. But first, let me introduce Lithoglass. We were founded in 2006. We have two sites, headquarters and production in Dresden, and an R&D center in Berlin. Both sites are ISO 9001 certified. And what we are doing and what our purpose is that we are developing and commercializing innovative wafer level packaging technologies with a focus on miniaturized SMD and COB type of packages. We do this in our specialized foundry and have a focus on optoelectronics and MEMS. Now, within this optoelectronic focus, there are several applications I would like to show you today. First, with our technologies, we're able to have miniaturized hermetic packages that are compatible to SMD or COB processes. And wherever possible, we target to enhance the optical performance of the device using our materials. With the semiconductor processing technologies that we use, we have excellent precision, and it's easy to scale up volume production for these types of materials. Now, the following examples will be about emitters and detectors. So first is about UV LED. Here, the packaging normally is still a TO can or a ceramic package. And with UV LEDs, or especially in the now en vogue field of UVC LEDs for disinfection, these packages have the drawback that a lot of the emitted light is actually lost in the package at the sidewalls of the package and then turned into heat. Now we have a solution where we can integrate a mirror structure into the window that's placed on top of the LED. So you see here the LED chip emitting a lot of light to the side is hitting a mirror structure and is then redirected to the top. So we can extract much more light from the device. With that, we have a much better thermal performance. And using our technologies, we can have very small outlines. We can do arrays and make these materials for hermetic or non-hermetic packaging. With laser diodes, we have a similar approach. Here also, a lot of TO cans still used with the disadvantages that are commonly known. We can make lids with integrated reflector here with a 45-degree angle, turning the side-emitting laser diode into a top emitter. The mirrors can have coatings that are adapted to the wavelengths needed, and we can make this as a fully integrated housing or a single mirror parts. Again, very small outlines, arrays, possible hermetic or non-hermetic packaging, depending on the customer's needs. For optosensors, now this is a very simple package I'm showing here. So a piece of glass being glued onto the optosensor to do a chip-on-board molded package. Now this will have very poor reliability and also very poor optical quality because there's glue within the optical path. The glue can discolor, it can have bubbles when it's applied. You can have particle contamination because normally this piece of glass is stuck on in the back end of line. Now we have a front-end process, which is a glass deposition process, which we can use to seal the sensor directly at the surface. As a low temperature glass deposition, the glass is matched to the silicon in terms of thermal expansion. It can be structured by liftoff to leave open the contact pads. So you can do the normal back-end packaging, but the sensor is already protected by glass film. Another solution we offer is a fully inorganic package. We make a lid with a standoff dam. This is hermetically joined. It can have optical coatings, and this is then placed over the already assembled chip on a flat submount. Again, this can be very small. We can add optical features. This can again be, of course, in arrays, and depending on the submount and how it's attached, can be hermetic or non-hermetic. In the field of image sensors, what is very commonly used is a glass lid with a standoff made of epoxy and an epoxy dam. This works well in smartphones for small sensors, but the larger the sensor gets, the more you have a problem with the CTE mismatching of silicon, epoxy, and glass. and so reliability will be an issue. We have a technology to make glass caps. It's glass with a glass dam, and even if this is then attached with the glue, the reliability will be much improved. And we have processes to either do this on chip level, but preferred on wafer level. Under clean room conditions with a very high yields due to the very clean environment. Yes, so this was a short overview. Here, some examples for other customized opto and MEMS components that we do. Wafer level capping as described, but also cavity wafers in silicon, glass, reflector wafers, microstructured glass substrates. And in our foundry services, we also offer bonding services, low temperature glass deposition, wet etching of all sorts, metallizations, laser structuring, dicing. Thank you for your attention. So we are here at Photonics Plus. Please visit our booth, drop us a line if you have interest. We'd be happy to explain more. If you're watching this outside of the conference, do contact us at sales@lithoglass.de or our website, lithoglass.de. Thank you very much for your attention.